Assalamualaikum and hello everyone. My name is Nur Amna Inshira binti Abdul Aziz, and together with my friends Nur Aisyah binti Aminuddin, Nur Amira Najiha binti Muhammad Asadin, Nur Atira binti Kamal Hisham, and Nur Amisha Aisyah Nina binti M Amizan.
Without further ado, let's begin our presentation.
Hello everyone, I am Nur Atira, and today I will introduce our presentation on the application of chromatography in sugar analysis of apple and orange juice. Analytical chemistry is the branch of chemistry that focuses on identifying and measuring the chemical components in a substance. One of the most important techniques used in the analytical chemistry is chromatography. What is actually chromatography? Chromatography is an analytical technique used to separate, identify, and quantify the components in a mixture. Separation occurs because different substances interact differently with the stationary phase and the mobile phase, causing them to move at different speed. Have you guys ever wondered how many types of chromatography do we have? There are several types of chromatography, including paper chromatography, thin layer chromatography, which is also known as TLC, and high performance liquid chromatography, or we call it HPLC. HPLC is widely used because it provides accurate and reliable results, especially for food analysis. In this presentation, we will focus on using chromatography to analyze and compare the sugar composition of apple juice and orange juice. This helps identify the different sugars present and supports quality control in the food industry. The objectives of our presentation are to analyze and compare the sugar composition of apple and orange juice, understand how chromatography separates sugar components, and explore its application in the food industry. Thank you.
Now, I will explain about the principle of chromatography. Chromatography is an analytical technique used to separate the components of a mixture. The separation occurs because each component has a different affinity toward two phases, the stationary phase and the mobile phase. The stationary phase is the fixed phase, such as chromatography paper or the material inside the column. The mobile phase is the liquid solvent that carries the sample through the stationary phase. As the sample moves through the stationary phase, each compound travels at a different speed. Compounds that interact strongly with the stationary phase move more slowly. On the other hand, compounds that interact weakly move faster with the mobile phase. In sugar analysis, sugar such as glucose, fructose, and sucrose are separated based on their differences in polarity and solubility. The result depends on type of chromatography used. In paper chromatography, the separated sugars appear as different spots on the paper. In high-performance liquid chromatography, or HPLC, the results are displayed as a chromatogram with different peaks. The retention time is used to identify each type of sugar, while the peak area indicates the concentration of that sugar. Overall, chromatography is an effective technique for separating, identifying, and analyzing sugar components accurately.
Hi, Assalamualaikum, and I will be explaining regarding of application of chromatography in sugar analysis of apple and orange juice. Have you ever wondered why apple juice and orange juice have different level of sweetness? This is because apple juice and orange juice contain sugars such as glucose, fructose, sucrose, but their sugar composition are different. So, chromatography is applied to analyze the sugar content in apple and orange juice. Do you know that fruit juice contain several types of sugar, and the most common sugar are glucose, fructose, and sucrose. These sugar contribute to the sweetness and nutritional value of juice. Apple juice usually contain a higher amount of fructose, and fructose is the sweetest natural sugar. So, apple juice generally is sweeter, and it also contains moderate amount of glucose and sucrose. On the other hand, orange juice has a more balanced distribution of sugar. This is because it contains glucose, fructose, and a slightly higher amount of sucrose compared to the apple juice. Sugar analysis is important for several reasons. First, it helps to ensure accurate nutritional labeling on food products, and second, it allows us to compare the sweetness level of different juice. Third, it can help detect the added sugar and or adulteration in commercial juice products. So chromatography plays an important role in this analysis. It separates the individual sugar present in the juice sample. The separated sugar can then be identified and quantified. This allows us to compare the sugar composition of apple juice and orange juice accurately. So, in conclusion, application of chromatography is allow us to compare the sugar content of each type of juice in this work. Thank you.
Hi, I'm Amna. Now I will explain the material, methodology, and how the data is analyzed using high-performance liquid chromatography, or called as HPLC. To perform the sugar analysis, several materials are required. These include apple juice and orange juice sample, standard sugar solution, HPLC systems, the mobile phase, and a filter apparatus. Before the analysis, the juice sample are filtered to remove plum or other impurities. If necessary, the sample are diluted to ensure more accurate and reliable results. Next, the prepared sample is injected into the HPLC system. The mobile phase carries the sample through the chromatographic column, where the sugar are separated based on their interaction with the stationary phase. Then the separated compounds are detected by the detector. The detector records the separated compound and generates a chromatogram. Each peak represents a different sugar. The retention time identifies the type of sugar, while the peak area indicates its concentrations. Finally, the chromatogram obtained can be compared to study the sugar composition of apple juice and orange juice. The results, interpretation, and concept will be explained in the next section. Thank you!
Now that we have learned how paper chromatography works and how the experiment is carried out, let's take a look at the results of the sugar analysis for apple juice and orange juice. As you can see from the chromatogram shown, several spots appear after the solvent moves up the chromatography paper. Each spot represents a different sugar that has been separated during the process. To identify these sugars, the position of the spots are compared with standard sugar samples containing glucose, fructose, and sucrose. Since each sugar has its own characteristic RF value, we can identify the sugars by matching the sample spots with the standards. Based on this illustrative example from published literature, both apple juice and orange juice contain the glucose, fructose, and also sucrose. However, the fructose spot in apple juice is generally more prominent, meanwhile orange juice shows a more balanced distribution of all three sugars. This simple comparison allows us to understand that different fruit juices naturally contain different sugar composition. So, what do these results actually tell us? The main point is that different fruits naturally contain different proportion of sugars. This variation is influenced by factors such as the fruit's type, its variety, and also its stage of ripeness. You might be wondering why the sugar spots appear at different positions on the paper, right? Let me tell you. This happens because each sugar interacts differently with the chromatography paper, which acts as the stationary phase, and the solvent, which is the mobile phase. As a result, each sugars travel a different distance and form its own spot. By comparing the RF values with those of the standard sugars, we are able to identify the sugars present in the fruit juice samples. This is exactly why paper chromatography is such a useful analytical technique. It allows us to separate and identify different components in a mixture using a simple method. Now, let's look at the factors that can affect the quality of the chromatographic separation. Although paper chromatography is simple to perform, obtaining clear and accurate result depends on several important factors. For example, the composition of the solvent affects how well the sugars move through the paper. Temperature can also influence the speed at which the solvent travels. In addition, if the sample is too concentrated, the spots may become too large or overlap, making them difficult to identify. The quality of the chromatography paper and the development time are also important because that affect the clarity of the separated spots. Therefore, controlling these factors helps ensure that the results are clear, reliable, and easy to interpret. Now that we have seen how paper chromatography works, let's explore how it can be applied in real life. Paper chromatography has many practical applications, especially in food analysis. It can be used to compare the sugar composition, not only limited to fruit juices, but also other fruit products. It also supports food quality control by helping identify the presence of different sugars and contributes to nutritional labeling. Besides that, paper chromatography is widely used in schools and laboratories because it is affordable, easy to perform, and provides a clear demonstration of chemical separation. And lastly, although industries often use more advanced techniques for detailed analysis, paper chromatography remains an excellent method for learning and understanding the basic principle of analytical chemistry. Finally, let's summarize the key points from this video. Paper chromatography is a simple and effective technique for separating and identifying sugars in fruit juice. And by comparing the RF values with standard sugars, we can identify glucose, fructose, and sucrose in apple and orange juice, making it useful for studying and comparing their sugar composition. Overall, this application shows how analytical chemistry can be used to analyze everyday food products in a simple, practical, and meaningful way. With that, thank you for your attention.